Thank you for allowing me to present. I have no disclosures. So our research just starts with a simple observation. What is the role of creeping fat in Crohn's disease? As surgeons, we've long recognized the growth of mesenteric fat wrapping around the bowel as a hallmark of Crohn's disease. It's a marker of strictured bowel and a guide to our surgical resections. But its overall role in Crohn's disease is poorly understood. So is creeping fat just an innocent bystander, a marker and nothing more? Or is there something else going on? One of the problems with trying to figure this out is that there's no real good optimal animal model to study Crohn's disease. The models that are currently used often use intensive gavages that are time-consuming and probably more reflect an acute bowel injury model than Crohn's disease itself. So we developed a surgical model using an anti-mesenteric colotomy that we have found faithfully phenocopies the phenomena of creeping fat in mice. This model allows us to take a very granular look at how the creeping fat interacts with the surrounding bowel. Compared to our control specimens, we've been able to show the development of creeping fat in our colotomy model, and most importantly, subsequent bowel stricture formation in the areas of the creeping fat, just like in Crohn's disease. Immunofluorescence staining shows both adipocyte and fibroblasts infiltrate our surgical site and are present in the areas of stricture formation. So where do these fibroblasts come from? Our theory is that they come from the creeping fat itself, and these adipocyte-derived fibroblasts from the creeping fat are some of the key mediators of bowel stricture formation. There's a lot of recent exciting literature showing fat isn't a benign cell, but participates in many disease processes and a key mediator of inflammation. So in order to test that, we developed an adiponectin-3 lineage tracing system, which labels all adipocytes and their subsequent derivatives green with GFP. And then every other cell lights up with tomato red. We stain for various adipocyte and fibroblast markers, and we observed that green fat cells lose expression of adipocyte lineage markers, such as PLIN1 and PPAR gamma, and acquire the expression of fibroblast markers, such as alpha SMA and PDGFR alpha, and behave like fibroblasts by producing collagen and responding to TGF-beta signaling. But we wanted to go deeper. We wanted to look at the transcriptome level, looking at the RNA itself. So we wanted to use RNA-seq. Now this was a little bit difficult because fat cells float, and so we really had to work on our protocol for tissue digestion, but we were finally able to isolate both the bowel and the mesentery. First, we sent our samples off for bulk RNA-seq to validate our protocols, and we're pleased to find that all the resident populations that you would expect to find in mesentery and bowel were there, such as smooth muscle cells and various immune cell populations. So our next step was look at the single cell level. And what we saw with our single cell RNA-seq for fibroblasts was we found 7 different fibroblast clusters within the creeping fat. So then we used cytotrace, and we were able to show several clusters have a distinct differentiation trajectory for fibroblast-like cells that we were interested in. In particular, subpopulation 2 shows increased levels of RUNX1, which is crucial for fibroblast commitment in progenitor cells, along with fibroblast markers such as Col type 1 alpha 1 and SFRP2, which denotes a mechanofibroblast type phenotype similar to inflammatory fibroblasts seen in skin wound healing models. They participate in wound remodeling, attract inflammatory cells, and induce scar formation and collagen deposition. We're able to see the same fibroblast population in the strictured bowel and a lineage commitment trajectory as well. And we see subpopulation 2 with the same inflammatory mechanoresponsive phenotype is seen in the strictured bowel as well. So using our adiponectin-3 system, we're able to show that this particular subpopulation of fibroblasts is partly also derived from adipocytes itself, which is an exciting roadmap to future research. And here we see the same adipocyte-derived fibroblasts are present in the strictured bowel as well. So where do we go from here? The biggest question is, does this in fact match human creeping fat and human Crohn's disease? I wish this conference happened about a month later because we have been collecting pediatric Crohn's disease patient specimens, and these samples are pretty much back, and we are analyzing the RNA data right now. And I suspect that we will have that data soon. Clearly, if we see the same subpopulation of fibroblasts in the human data, 1, it helps validate our animal model as something that can help us replicate key aspects of Crohn's research, and 2, show us that we're on the right track, that the fibroblasts and the adipocytes from the creeping fat are key mediators in Crohn's disease. So next we want to really drill down on this subpopulation, trace their origin, find specific markers, and get linear into what's causing these fibroblasts, these adipocytes to change into fibroblasts. An exciting step that we're also taking is sending these samples for Visium 10X, which is a tool to look at the transcriptome in three-dimensional level. As surgeons, we know the physical space is really important for the disease process, so understanding and looking at the RNA in the 3D will help us to understand this relationship. And ultimately, our goal is to find targeted areas of therapeutics that, ironically, I hope, will one day make Crohn's resection for bowel strictures a thing of the past. Thank you. I really appreciate being here for the foundation, for the grant. A lot of team members to thank as well, but I really hope to come back and share our more mature data in the future. Thank you.
We are a little bit behind on time. Is there one question in the audience? Your research was too overwhelming. I have a quick question. What's your theory how this happens and why? So obviously this is truly important for, if you can find out this is really the cause for the strictures. Why does the body do that? What's your theory for that?
Yeah, that's a great question. So I think there's a couple sort of things going on. One, I try to think of this as sort of a low-grade forest fire happening, throughout the body. It's obviously an autoimmune process, right? And so what's turning this on? And so there's some sort of trigger of low-key inflammation. One we think that's possible is that the microbiome is obviously probably involved as well because dietary modifications seem to have effect on Crohn's disease. So that's one thing we're looking at. Two, the other thing we're looking at is mechanical, right? Obviously Crohn's disease can happen anywhere from the mouth to the anus, but there's a reason why most of us, when we do these stricture resections, happen in the ileocolic section next to the sort of the colon as well. So I think there's sort of a mechanical process going on, but we really want to be agnostic to what's causing it and to be really open to what it could be. It could be, who knows, some undiscovered virus that we don't know. So we're trying to be really agnostic to that process.
Thank you very much.
Thank you.